Hello. Welcome to the channel. So something happened with my previous stream which I started, so I have to start my stream again. Give me a second, let me do the stuff. So wait a second. Content live. I would need to couple of things. I would require to change the link of my stream now. So let's see. Copy, create a new, create, and create. First thing first, let me auto. Good, nice. Okay. Wait a second. What? Output? Yeah, that looks good. There are a couple of more settings I would require to do, and then we can start the thing. Let me just switch it. I am just posting a story based on live. And then share the story, and I can come back here and we can start working on the project now. Okay, so just to give you a base general introduction regarding what we are gonna be doing on this live session is I'll be I'm using a MPU 6500 gyroscope plus accelerometer sensor. Okay, so I am gonna be interfacing with STM32. So in this use case, in this use case, that there are a lot of different libraries available online, but for me to understand a lot better about the sensor and a lot of different things, I'll be creating my own library or today in this video in the live stream, and maybe this live stream will be divided into a couple of more streams. Maybe like as creating a library is not an easy task, it will be a multiple uh, stream thing. So before we get started directly creating something, we need to set up the projects. So in this case, I'll be using VS Code and CubeMX, STM32 CubeMX for the thing. Using STM32 CubeMX will help us to set up the environment for the microcontroller. And then we have VS Code with PlatformIO extension. We will be using that for our uh, programming interface, or like you use IDEs for programming. So I'm gonna be using VS Code paired with Platform IO. Okay, so let's get started. Okay, I am not sure. Just a second. Just a second. All right, let's first. I have CubeMX over here. I'll be using. So I have a small setup already made. I'm using an STM32. Uh, what was it? G030. Okay, a small microcontroller board which I have here for development, and I have an ST link connected over here through a wire with the interface of UART plus debug interface. Along with I have a as you can see, this is the MPU 6500 sensor. So this is just a module which I'm gonna be using for interfacing, and there's a small switch as well which we can use for assigning couple of tasks. So let's get let's set up our environment for the microcontroller. So I have STM32G030 F6P6 in my case. Well, I believe. Okay. We do need a data sheet and rest of the stuff. So I have opened the data sheet for. I don't think so. I'll need a data sheet for the controller because yeah. Let's see. Start. Okay, here we go. And let me just try and change. I would need to restart. I'm gonna change the UI first. Uh, so it will be much more visible for everyone. Okay, I'm gonna set it up again. STM32G030 F6 B6 start a project. Now it's much more visible, right? Alright, so first I'm gonna name the project MPU 6500 LIBRAR library. Basic, then we choose make file. code generation. Uh, Copy only the necessary files, library files, generate peripheral files, initialization as a pair of C and H file. Okay, rest of the stuff looks good to me. Ta-da, 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 ta-da. Okay, for the clock configuration, right? My bad. For the clock configuration, which I'm gonna be setting it to the max frequency is 64. Let the rest to be done by itself. Okay. Now we go to connectivity. I'm gonna be using UR2 asynchronous. Keep the rest of the stuff as it is. Then I have SPI1 full duplex master. Okay, I'm gonna set it to 64. Yeah, I'm gonna be setting up to 64. The prescaler for the baud rate as 1000 kilobits per second, like which is almost 1 megabyte per second, megabits per second. Okay, and what else? Yeah, that's good. And we I'm just gonna reset state. My bad. Full duplex 64 SPI clock. I'm just changing these things for my own reference. GPIO output. I'm gonna enter as SPI1. Yes. Okay. Chip select. Then switch. Okay. I have an onboard LED. So I will also set as a GPIO output. Enter as SLED. Okay, I use this name. And what else do I need to configure? Okay, we have A11 and this one as GPIO input. Enter as switch. Okay, that's it for the basic setup. We will check later on what we need to do. I believe you would need somewhat some level of understanding of how STM32 QMX works, as this is not a tutorial for like a beginner. But I will be trying to write a library for this particular sensor so anyone can actually easily integrate and use those functions for their own purposes. So okay, not sure did I the path. I'm gonna change project STM32. That's it. And basic everything looks fine to me. I'll click generate code. After the code has been generated, I will open the folder. Here's the folder. Okay, and wait a second, something looks, yeah, I would be needing this two files and paste it inside here. And now after refreshing, this is the main core files. Okay, these are all the files which we generated from CubeMX. I just added a board file which basically has a configuration for this STM32 configuration. I'll show you what it is. And the platform.ini initiation file. Okay, I'm just gonna open this folder in the VS Code. Close the other one, and I say yes, I trust this author. Okay, I'm gonna make it a little bit bigger so it is much more easier to read. So this platform.ini file has the setup for the environment as so PlatformIO will use this as the source, this as include, then this is our environment for the board configuration framework which we are gonna use in upload protocol. Okay, and the board configuration which I was saying about talking about was this. Okay, so this has all the settings for my microcontroller which I'm using as STM32G030F6P6. Okay, uh, if you require this file, do ping me in the comment section. I will upload it on a Google Drive and share the link for this file if you are using the same thing. I believe platform I know. Okay, so I'm just gonna create a new, my bad, create a new folder, lib, and inside lib I will create a new folder, MPU6500. Wait a second, my bad. I need to first go a new terminal. We do a platform IO init, and it says it has already been done. So there is, we can now create lib folder. Inside the lib folder we create a new folder, MPU00. Inside this I create a src. Okay, now in this I create a file, MPU6500.h, and another file, MPU6500.c. Okay, keeping the stuff. Now what we need, I'm gonna create a separate file. Okay, this is our main file where I'm just gonna add two functions. Okay, like if you have used an Arduino loop and setup, I'm gonna create a custom function. Okay, as setup. Okay, and a function loop. Okay, save, close this. I'm gonna create a new file inside the source which will be known as custom.c. I just named as custom, and include same custom.h. In h I'm gonna do if and if custom underscore h underscore underscore uh, define hash and if. Okay, wait a minute, if okay, include hash include custom.h. Now I'm gonna create a function inside this guy as void setup void and void loop void. Okay, these are the two functions, and we will declare this function over here, void setup void loop. Okay, these are the functions we made, and the last thing remaining is we need to include this hash include custom.h. And now if we compile, it should be able to uh, fix the issues. So just ignore that. As you can see, it has finished compiling. That's good. Now what are we gonna do? The next step for our thing is, we created two files, right? We just do the same thing in header, hash if and def MPU 6500 underscore h hash define hash and if save and hash include MPU6500, right? And I'm gonna do the same thing in the custom.c file. I'm gonna keep the custom.c file on the left, and as well as custom.h file on the left side. This way it will be easier to work with, right? I'm just gonna do it like so. I will include hash include MPU. Okay, wait a minute, something is off. Rename MPU. Wait a minute, something feels off. mm, Delete, move MIO new terminal. Okay, that's what I said. I needed the this folder. Now it is okay. Good. We paste over here, Control X. Now it should be the issue should be fixed. I don't need include anymore of this. So hash include MPU 6500H. Good. And first thing first, we create an init file to just to make make sure that everything is working fine. Okay, void MPU underscore 500 underscore init void. I'm also gonna declare it here, hash include, sorry, my bad, void u6 underscore init. Actually we will change this later. Okay, for now I just need to check MPU init. My bad, colon. We try and see if it is okay. Something says was here. Oh yeah, my bad. In the header file, we just end it with a semicolon and we try it again and it should compile. No issues. Now, what are we gonna do? I believe I'm gonna stop the music because I believe it will create an issue later on. So, pause the songs and I'm gonna hide this thing as well. So, yeah. Now, I'm gonna. So, we do need to have a look at the MPU datasheet and the register thing. Okay, register map. So we just a second. Yeah, as you can see, this is the MPU datasheet, MPU6500 datasheet. As I'm not actually be explaining you how things are be working, we just need to concentrate on simple things like the SPI communication. I will be using SPI communication. We will be doing some other configuration inside it, and I will need the register map. Okay, so we check what are the other thing, application note, user guide, and this download. Good, this is what I need. So I will open this guy in a new folder, MPU 6500. Save it here. User guide. What is the user guide talking about? Okay, 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 okay. I would require the datasheet to be downloaded as well. Okay, I'm gonna look for. So we go back, we paste here. This one is the datasheet, and this one is the register map. Close this, close this. We won't be requiring this anymore now. Okay. To begin with, what we require is to we will create a loop first of all. Okay, the loop would be to blink the LED on board. So I'm gonna create a separate function like void the blink void. So we I would require to include hash include gpio.h. So hull GPIO toggle L S S LED GPIO port S LED GPIO pin and hull delay of 100 ms. Okay, LED blink. I'm just gonna copy this part and paste it over here. Okay, save, compile, and before I upload, I'm gonna show you if it is working or not. Okay, so now I am gonna upload and this LED should be blinking. Okay, I'm gonna just hold it like this. So upload. As you can see, there's an LED blinking now. Okay, like this. So yeah, it is. Yeah, as you can see, there's an LED blinking. So our code is running, and I will be using this LED blinking code just for a reference if there's any uh, blockage in the code, like if it is blocking anywhere, okay, in the loop itself. So I'm just gonna so I use a AI based application just to write the comments and stuff. So and we can also use this for optimizing, but to create basic stuff I just use this. I don't need a lot of different stuff. Let's just keep it like this. So you get when you hover on the function, we get the description of what it does. Okay, now as I told you, we will be taking reference of the register map. Okay, so here we have lot of registers over here, okay, inside the sensor. So this register, we will be accessing this register to read the information and to write the information. uh, why write the information? We will be setting up some configuration. This configuration will help us to get accurate data, or to set the sensor in sleep mode so it does not consume any more power and these and that things. So this is how we will be able to configure a lot of things. There are different register for a lot of things. There are almost, okay, wait a second, let me just sign into my adobe. What happened? Wait a reveal in a file explorer. Ta-da, ta-da. It's already signed in, so what's the problem? Hmm. Oh, it's signed in automatically. Okay, whatever. So, I'm gonna create a list. Okay, what are the registers we will be needing to work on? Okay, with the help of our AI tool, I will be able to create some things. Okay, first we just create a type def enum MPUs. I will start with double underscore MPUs 6500 register addresses, and we keep it as register address. Okay, inside this we will be able to um I'm gonna store a lot of different register and their addresses. Okay, the name of the register and the address. So we just start with this one first, is equal to 0x13. We set at hex. I have a AI tool which helps me to it guesses what I'm gonna write, and we will just cross verify if he's giving us the right information. Okay, so xg high and low, 13 14, 13 14 15 16 17 18, 17 18, good. Then we need the config is equal to 1a, sorry, 0x1a. access acceleration config is on 1c. Okay, gyro config is on 1B. Wait, okay, my bad. GY. Wait. So sometimes it doesn't work as I want. 1A, 1B. Then we have one more configuration. Underscore is equal to 0x1D. Okay. Well, I did made something like this. Oh, my bad. One thing, no semicolons, commas actually. My bad. The next uh register I want to copy the addresses for int pin config. Okay. I have made this thing on my previous other test project. Let me just check. I'm just gonna copy this section and we paste it over here. So I've already made some things out. Okay. Okay. Self test. Actually, I don't require a self test. Or okay, don't need this. L 1E 1E 30. We just check low power output frequency. Okay, well, it's it I'm not gonna be using this, but if you guys like after completing the thing, if the user wants to configure anything, they can. Okay, okay, okay. User control power management. Okay, 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 okay. Not bad. Now I'm gonna create a structure. Uh, type def structure. Underscore MPU 0 structure and s underscore MPU 6500. Okay. struc structure setup. Wait, MPU underscore 500 setup setup. Then over here now, as I will be configuring it for the SPI, we include SPI.h, and from the SPI.c I need this SPI handle, and we say hardware. Wait, no, actually no, wait, hardware, but we create one more struct uh, MPU 6500 underscore SPI. Okay, and SPI, and I will put this inside and will require the GPIO as well. GPIO. Wait a second. GPI.c, GPIO inter type def, tada, GPIO, GPIO type def, not int actually, control C, control V, equals to CS underscore port, then UN16 CS. Nice suggestions. Good. And yeah, we do set up the configuration for the SPI. Then we have gyro setup, gyro structure underscore MPU 6500 underscore gyro gyro. Right, nice. Okay, good. Just spacing out everything a little bit so it is easier to understand what's happening. Okay, so while we initialize, we need the user to configure the setup, like which SPI to use and these things. So I will in it, not in net actually. Just a second. First, we create a struct an instance of the structure. Okay, by doing s underscore MPU, and we say I underscore MPU 6500. We create an instance of the structure. Okay, now what I'm gonna do is we use this for setting up the configuration. So we have default void MPU 6500 default config, not actually void. Yeah, s underscore MPU pointer to the MPU 500. This goes same as MPU 500. Okay, void MP. Wait, better for me to directly copy this guy. So now we create MPU 6500 dot setup dot SPI dot hardware equals to h hardware SPI1, then MP underscore MPU dot setup dot SPI dot CS port. CS port will be SPI CPS GPIO port and CS GPIO pin. Right. What is this issue? Ta-da, ta-da. I believe the repair key cannot be assigned to an entity of type W. Wait a second. Hmm. Just a second. I did implemented something similar over here. So let me just check. Yeah. Oh, okay. Wait. My bad. That's a pointer actually. Pointer to that. Now it should be the error should be solved. Okay. Whew. I will be taking reference of a lot of different places. So MPU default config p underscore MPU. Okay. Mm-hmm. I would need to read and write. We created two functions. Void MPU 6500 SPI read. Void MPU 6500 SPI write. Wait a second. Mm, okay. I have just opened. So there is a register called UMI. Okay. We need to read that first to identify if this is this one. So if you go down, we should get 0x70 for the data over here. So I'm just gonna transfer this. Hey, okay, I have another one open on the browser to my right, along with some reference code which I was working on previously. Okay, so to write and s under MPU 6500 pointer to this p underscore MPU 500 comma, we need a new and new. We only send 8 bit of data at a time. So we write data to is like pointer to the data data. Okay, now first thing, we create a in SPI communication, we need to pull the GPIO, the CS pin low, so it will tell the sensor that it's gonna start a communication. The master is gonna send some data, or he wants to read some data. So we write a GPIO all underscore or GPIO underscore right. And over here we have p underscore pointer to this dot dot spi dot port comma p dot setup dot spi dot cs pin comma, it should be low or you can say 0. Then we use something like this, hal spi pointer tada pointer to the data, then spi, sorry, we need, my bad, wait, let me just spi transmit pointer to the data underscore spi underscore transmit. Now I need a pointer, p underscore s MPU6500. Okay, to set up to SPI to hardware. Now we need a pointer to the data. The data would be pointed to the data. Then the size of the data is size of p underscore data underscore the timeout. I'm gonna create a function called over here, not the function. You int 8 time out, and in the default we p underscore mpu dot setup dot spi dot timeout equals to 100 ms. So p underscore this to setup to spi to timeout. Now after transmitting we actually stop the, we pull up the SPI pin comma 1. Okay, what is this? So nice. Okay, damn, I need to turn this reference. Okay, GPIOX GPIO pin state is 0, timeout is this. Okay, and I will just ask my to write a inline comment and this stuff for this, so later on we can actually understand what is happening. Yeah, just let, just wait for some time. It did not, wait a second, I'm just gonna create type def in num view under 6500 underscore cs state state cs select comma cs uh okay, wait, cs enable en disable, done. I use the same thing over here, cs enable C CS disable, and we ask the AI to generate the code again. Add a docstring comment and a inline add docstring and inline comment. Let's see. Wait a minute. Why is it not adding the inline comments? Add a and a on for this code. Hmm. Yep. Yeah. Nice. Okay. I insert this. I remove the spaces. Hmm. If you hover, there are too much things going on. Do we need a lot of detail? Maybe yes. So I'm just gonna add details and do it like this. So yep, nice. I minimize this, and we now create the same thing for this guy as well. Uh, hal underscore GPIO underscore right. Wait, it's better for me to copy this two line of code. This tada 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 tada. Okay. Now, while reading, there is a couple of things which are little bit complicated. So first, let me just write down the pointer to MPU 00, comma, and then what we need is the address, the pointer to the data, and the size of the data. Okay, so we go for the u and 8 add RE. Second, we use, I'm just gonna use a short add comma, then un8 pointer to the data, pointer to the data. Okay, and what else we need? We need a size of the data, so un8 underscore size. Okay, uh data size, I believe un8 would be sufficient for this function. Okay, before we do, to access any of the registers for reading, we need to offset it. We need to add 80 hex 0x80, I believe. Let me check. No, 80. Wait a second. Hmm. Yeah. Something was written over here if I'm not wrong. Mm. Two six five double zero. Oh, these are the these are for C. I needed for SPI. Pa, 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 pa. Source. Even if it is CPP offset. Uh, yeah, we can get actually a lot of different things. Enable gyro access, enable accelerometer access. Nice. Get value. Nice. Uh, these are for I2C. That's why. Just a second. Okay, so yeah, it's 0x80. I am just actually looking at some other thing. Pa, 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 pa. Maybe we can just ask our AI for some help. SPI read for the MPU 6500. See, I told you, Xerox City. Thanks. So, what I do is first we create a new U and 80 read address is equal to underscore add 080. Actually, I don't need this if I do like this, right? Because this guy did the same thing. Why not? Now, we after doing this step, we will first transmit this data and then we retrieve it. So how are we gonna do is I'm just gonna copy the transmit code, control X, paste it over here, and transmit. Pa-pa-pa. Transmit the data. Okay, transmit the data and the size of this address, it should be 1, and the timeout. Okay, and then we receive underscore spi underscore receive mm, underscore MPU6500 dot spi dot hardware, and pointer to the data, and um size size data size and the timeout. So for the timeout, I'm just gonna copy this section, paste it over here, and we have it. What is gonna do is after adding this offset value, it will point the address over there, and the sensor will start transmitting the data. So the data will be stored at pointer to the data, and it will only accept the size which we provided. Okay, and we create a comment so it's easier for us to monitor it on the later stage how things go. Okay, it's actually creating okay, my bad. Hmm. Details. Okay. Read and write function is created. Now I will need to add this guy over here as well, and this guy as well. Hmm. What do we need? What else do we require is to set up a basic uh, configuration. We have a sleep register which we will be using. Temperature disable register bit. Then we have clock select, and we can actually use some references from these functions. Not this one. Get value from FIFO. Get correction value. Get temperature. Okay. Mhm. So first we read who am I? Okay, first step for today. to check if we are able to send any data. U and 8 U6500 O I S underscore pointer P underscore MPU 6500. Now over here, what I want to do is I want to read the data and event 8 mm, data. Okay, and we use MPU 6500 underscore SPI read P underscore MPU 6500. The address will be W who am I, and the pointer to the data comma size of data. Okay, and then we return data. As well as I would like to actually set what is happening. uh what is the issue? Let's compile and see. Error. Oh yes, I underscore uh this should be resolving this issue. Good, thanks for the like. So now who am I? You and date. I want it to be also setting up you and 8 uh who am I? Actually, this will be fine. And I use this p underscore dot who am I equals to data. We will call this guy and the init and p underscore. Okay, now what I'm gonna do is if MPU who am I equals to 0x70, then we blink this LED. Okay, and we can also actually see if the data who am I In debug, I'll watch this mm, instance of MPU 6500.omi and we debug. Let's see. I'll create a breakpoint and a breakpoint over here. Two breakpoints, so we know. Okay. The initial value is 0. We play. Now it's gonna go in the init. It went and something seems to be off. Okay, it did exit that, but it did not enter this one. Who am I? Wait a second. I guess why. Pum. Because I underscore and the pointer should be like this. We stop this guy and perform it again. And again, this should be 0. It's and interesting. SPI read. I would like to monitor this as well. Okay. Read. Hmm. Oh, okay. Percent data, and then yeah, we needed to add the pointer. So my bad. I believe this should resolve the issue. Let's play it again. Mhm. Yep. Now if we yeah, if we convert this calculator 112, we get an hex value of 70. So if you see, okay, I'm gonna remove this breakpoints. So if you see this now, the LED is not blinking actually right now. Okay, if I play, okay, the LED starts blinking because it is able to satisfy. So the issue was that I forgot to add an ampersand. Hey, hello, Johnny. How are you doing? So that was the issue, and we resolved that issue. And so yeah, it reverts the value, and we can actually also. Do I need This only needs to be done in the setup function. So I just will take this comment and I'll just upload this. So what is the next thing I need to do is mhm, in the init we need to verify who am I, but how are we gonna verify? If it's not equals to mm, p underscore dot dot who am I? Ah, my bad. I should actually store this value like this. Uh, you and who am I? Okay. So dot setup dot who am I equals to 0x70. This way, I'll be able to verify the value. So basically this is the default and the user can change this thing. mm, p underscore MPUs dot setup dot who am I, then MPU 6500 setup device error. Okay, we will create an enum for the device error and stuff. mm, Type def enum MPU6500 errors error MPU underscore error. Okay, SPI error. Not like, well, let it setup error. We have okay. For now, let's do this setup error. We do so. I need to store the data somewhere. Pa, 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 pa. Ah, yes, we do structure and setup. Inside the setup, we have MPU underscore error as what should we name error itself? Setup error dot error. Nice. And then we can just say MPU pointer to that MPU 6500 dot setup dot error equals to MPU under 6500 setup error else MPU dot setup dot error equals to okay, and return we do a return. Ta-da! Okay. Ta-da, 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 ta-da. So mm-hmm. Okay, what's the problem now? Mm, yes, I understand. I don't require this. Kapal. Mm, we empty this thing. Empty. Oh wait, empty. Compile. I don't want to upload, brother. I just want to compile. Keep coding live irrespective. Watching. Yes, bro. Thank you. Yeah, man. Trying to make some library. Like I'm not doing a tutorial thing, but I'm teaching myself, you would say. Well, I'm taking reference from a lot of places for a lot of things. One of the place I am referring to my work is from this repository. Well, I forgot to. Yeah, this repository. So I've tested this library and it was working, but I want more flexibility in terms of calling the functions and stuff like that. So I'm making my own style of library. I believe it should be good because I'm gonna try and do this. Okay, so we have to. I also have to actually. This should be a default config locally. So I'm gonna do a weak void u6500 config to facilitate any if any change. Oh, like if someone wants to change something else. MPU 500, and I'm gonna do a all. Am I not allowed to put a delay? Why is that so? Like, well, I was allowed to do it over here. Is it because of the GPIO config? Oh, my bad. Da 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 da. I forgot. Okay, so I have GPIO and this. I believe I have the same thing over here, GPIO on this. Then why the hell I'm able to uh use hard delay? I'm gonna try and use the same shit. Wait a second. Hard delay of 50. Uh, See, I was able to use it. So damn. And we will call the MPU 6500 config um 6500. Okay. So the thing is, this is a configuration parameter which a user needs to do. If they don't, then the default config will be used. So by default, first default config will be called, and then on top of it, if any changes have been made, then those parameters will be changed, or else default things will be used. Like if I'm gonna do something like this only. First, let me copy and paste it over here. Pop, 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 pop. So this way, if I create the same function over here without putting a pump, wait, what happened? Without creating a, without adding a week, then I'll be able to use the same thing. Okay, dot setup dot let's say SPI dot timeout equals to 1000. Okay, what I'm gonna do is I'm gonna set a breakpoint at this point. Okay, because I also want to check a couple of things. We go to debug, and I will add I underscore MPU 6500 dot setup dot setup dot SPI dot timeout. Okay, so this is what I want to monitor. Where is it? SPI dot timeout as setup SPI timeout. Okay, what I am gonna do is before calling two different functions, we will check this over here and this over here. Close this and start the debug. Let's see. First of all, I hope there is no error. What font are you using? I am not sure, but this is my own um theme. If you go to the extension and like look for dark Aether, you will be able to find my theme over here. This is my theme. I haven't actually updated these things. I need to work on this. But yeah, you can use this theme. Like you will be able to use this fonts and the style. The font is, I believe, it is a default font, if I'm not wrong. I am just using like italic for different use cases and places. Italic, bold, underline. I'm not sure if I'm using any underlines, but yeah, I used to use underlines when I was configuring it. Let me just check. Where is my theme? Well, open folder. So this is my theme project. We well you can not this one, not this one. Yeah, this is my theme which I've made. So well, you can try it out and let me know how it is. I'm gonna be making some changes for like color theme because my friends are saying it looks a little bit grayish. So that is what I'm gonna update very soon. And yeah, okay. So coming back to this point, we will be seeing as it is 0 when it is initialized. We play, it comes here. Then again, wait a second, something was weird. See 100, as we set it up for 100, then it should change again to 1000. Wait a second, why it went to 232? Okay, hey, my bad. Actually, it should be UN32. My bad. Shit. Stop, 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 stop. And where's the other .h, we need to change things very critically. Where is it supposed to be? Over here, actually. You and 32, actually. This is what we want. Then again, we go debug. Is it visible? Are you able to see all my fonts and stuff? Or should I increase like this? Big. Is this good size of my font? No, I believe this is better. Okay, so we go back as it is 0 right now. We go 100. Okay, now it should change to 1000. So this function is needed as weak if the user does not call this function his, like he has to create a like this a function in his use case. Only then he will be able to utilize this. Okay. Okay, this is what I wanted to demonstrate right now. And moving forward, we are able to read the stuff. And for the reference, what is this guy doing? Is power management, his writing 00 in the power management. So I'm gonna write some basic stuff to follow his routine. 107, 107, 107, 107. So by default, it is set as 01 when the data is reset. So we want it to go on code 0. This will be a tricky stuff to do, I believe. Hmm. How am I gonna do this? I need to create a virtual register first. Yeah, we create a struct use 6500 underscore register. Uh, MPU underscore. What should I name it? It's kind of confusing, but still, I'm gonna use this as we will be using power management 1 PWR MN what is it MGMT underscore 1. Okay, then power management 2. Okay, we use this 2 to set the data. I would require it first we read the data from that particular register. Okay, after reading the data from that register, we then modify and write the data again, so it will not create any issues whenever we want. Okay, so we write a function to hmm, let's see how I'm gonna um let's see, void 6500 EGS register underscore. Hey, my bad. I needed to create this in this. Who am I? Okay, first we just I'm just gonna copy this part. Okay, and then what I will be doing is something is weird. Yeah, and then okay, register, right. So first we check which register they want to write into. So register address REGADD, register address, which bit they want to manipulate. So you int 8 bit pa, 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 pa. So you int 8. What else? Let's see how many we have power management. I create a enum type def MPU 6500 WR MGMT 1. Well, if I remove the type def, do I? Okay, let's see. What is the 0? Crocs, select, sorry, 0 underscore 1 underscore 2. Nope. Then we have temperature disable. We have Cairo standby. Then we have cycle. Then we have sleep. Then we have data reset. Okay. These are the bits which are responsible for different things. Okay. Ooh. Well, taking this pump. Let's see. Mhm. Mhm. Now I am a little bit confused. What has to be done? Let's see. I'm just gonna use send for like, let's see. Okay, now what we do is first s underscore mpu 6500. Okay, no, p underscore mpu dot um wait a minute, something's weird. Yes, register. So register dot power management one. Oh yes, I need to register address. First the register address, then the bit, and then you went it to set. Okay, second guys. And task. Okay, okay. hmm Just a second. So first I have to write if register address equals to power underscore management one, then we do a again if, wait, not if, I will use something which I used previously. uh, event 8 register underscore data. This has to be 2. Okay, so register underscore data 1 equals to underscore bit underscore bit underscore bit state. I use this over here. Bit state equals question mark bracket register data 1. We do an or operation and shift 1 bit. Nice. And not yep, that's what I want. Bit position. So we take this. Okay. Hmm. If bit underscore state equals to bit underscore set or bit state, so bit reset. Okay, else if bit state not actually bit position. Hmm. Right, nice. Set to reset, then it will goes inside this to power management. Okay. Hmm. Wait, register address equals to the eighth confirm data confirm data, then register underscore data 0 equals to register address and enum MPU underscore bit underscore state bit reset bit set mm, bit no bit no. So if there is bit no, ha Means I would hey, well, that's a great idea. Just use transmit void MPU 6500 register transmit S MPU 6500 star P underscore MPU 6500 comma register address reg address transmit. Okay, let's keep it like this. Uh, store, we store and then we transmit. What is the problem over here? Eh? Okay, okay. So, mm, bit set beat reset, bit set bit reset. Okay. Mhm. Okay, 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 okay. We also do this void 6500 underscore register get s MPU pointer p underscore MPU 6500 register address reg add mm, to get get you and 8 return 0 just for the sake of it. So what I want to do right now is to do if we need a switch case actually, that would be great. Switch case, the expression would be reg address, the case would be power underscore mgmt1, then the code would be spi read. Okay, we do an spi read p underscore this, then the address would be address comma, and then I need to store the data as well. You and data temp data. So temp data, comma, then what it is, size of the data, size of the temp data. Close this and we close this again. Okay, now it reads and it stores the data in this dump yard, and then I just register dot power management equals to temp data. Yes, nice. This way we will be able to easily do some shit. Case pwr underscore mgmt2. Okay. uh, thank you. Size of temp data. Yep, break, that's it. Thank you, thank you, thank you, thank you. The code is pretty much good. So we just do this for almost all the thing. Mhm, mhm. Which case register address, pwr underscore mgmt1, then sp dot register dot power management 1 equal to the bit state question mark. Good, thank you. Nope. So what we are doing right now is, if we store the data in this register which we created, then we take bit state question mark question mark this, and I'm just gonna try and compile this shit. I thought so something. So over here Type def PWR MG MT 1 bit bits. I tried to do it like this only. I tried to solve one issues, then go move ahead. What is the issue? Oh, um, well, let's see. Okay, bit underscore mark. Mhm. Okay, I want to actually monitor this. I underscore MPU 6500 6500 dot reg dot pwr mgmt underscore 1. Okay, custom dot c. What was the function I just created is for this guy. uh well, first this one. Okay, custom dot c. What I will do is in the setup itself, store point ampersand I, then r underscore mgmt1 underscore the bit position. I want the bit position. Sleep. Let's take sleep, comma, bit underscore set, and we will create a couple of these, and I'm just gonna temperature disable and actually don't need this device reset. No, let's take something else. One. Okay. After each one of these, let's see. Mm, okay. Okay. 64. 64. 0100. So as per the data sheet, sleep, we toggle the sleep, right? Then we have 72. 72. Sleep, and the fourth bit, the fourth bit is this one, temp disable, right? Yeah, and after this we should be able to check the 73. 73. Yep, good. We will also need to test if it is resetting or not. So, bit reset, reset, reset. Okay, I'm gonna create couple of this and debug again. This issue. Okay, retry. Hmm. Okay, do it again. Nice. 1, 2, 3, 4, 5, 6. Play. 1, 2, 3, 4. Stop and play again. Hmm. Stop. Play. 72. 1. Okay, it's setting and resetting. That's good. That's good. Okay. Okay. I do need to check for different things. So to transmit, we write event 8 data to switch case to register address. Okay, yeah, switch case to register address, then power mgmt1. If it is power mgmt1, then bum, data 1, data 1 equals to p underscore MPU6 register power mgmt this, and we do a SPI transmit. p underscore this, then pointer to the data is the data. Just let me cross verify this once. La 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 la. Not like this. Like this. In the init. After this, I will call the get function register.get. I will get the p underscore mp600 and pwr and imgmt1. Okay, after getting this, then I will store the data of p this, then r mt1 comma sleep comma set bit underscore set u6500 register transmit p underscore mpu6500 scroll pwr gm gmt1. So I will create a breakpoint over here. I will create a breakpoint over here just to check. Here as well. Bit reset, and I will do this again over here to get. Okay, so first Let me get the data. After getting, I stop this at this point. It records, then transmit. Before transmitting, then okay. Let's try this out. About hmm, hmm. What is the problem, dude? Actually, and then transmit. Mm, we try to debug again. Good. What is this? Warning. I don't need return again. Let's debug. Okay. Sorry. Delay 100 ms. Okay. Is there more breakpoints I've added somewhere? Uh, Stop. Debug. Not sure. Ow. Okay. 1, 2, 3, 4, 5. I guess I should not put the 5. Hmm. Whew. 65. Okay, it's one. Actually, wait. Debug, debug, debug. Okay, one 65A. Hmm. So that mean it is not transmitting. Hmm. It did not transmit. Hmm. Oh, damn. Data 0 equals to PWR MGMT1. Damn, 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 damn. Ah, shit. Damn. The biggest problem which I was doing. Let's go. Okay, it is basically now in sleep mode. I want to change it to. Okay, let's. That's nice. Okay, 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 okay. What is the duration? Stream. Hmm. Almost 3 hours. I'm also gonna add some flags. stru structure underscore underscore MPU 6500 underscore flags flag sleep bool. But to use boolean, I need to add hash include std b bool dot h, and that's right. Now give me a second. Ta-da. Oh, oh, that is it. That is it. So if the condition okay, the condition I have an example which I wrote a couple of days ago, so I'm just gonna use that. P underscore MPU dot reg dot power management ampersand one. Ta-da. What is this? Sleep. Ta-da. Ta-da. Wait a second. Ta-da. Sleep. Dot flag dot sleep. True. Else false. Now I will try to ask my guy to optimize this. Okay, this is actually giving me what I want, so I don't mind. We do the same thing. Okay. Oh, not here. Over here. Okay. Mm, am I using the stem data? I shouldn't. Pum 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 pum. Wait a second. I need a reference. Okay, this is fine. I just need to remove this stem data. Two. Mm, hmm. One U, one U. And this guy just go. Okay, tada, tudu, tadam. So this guy is setting the power management like the whole thing to 0, and we are getting 1. So I'm gonna set the first bit to 0, and then we can move forward. Okay, so that is the init. I will do this config. If I get wait, my bad, my bad, my bad, my bad. Um, from this point to this point. Okay, then over here, if in the else section we put this, but first we get the power management dumb shit. Then I change the first order of bit to 0. I reset this bit, and then I remove, I transmit, and that's it. That's what I want to do for this guy. And in this section, who am I? Okay. Uh, if Papa, the error. What was it? This is I underscore MPU's error is not true, is not true, then we blink the LED. I believe this should not cause any error. So, yep, my LED is still blinking. Mm, if you can see the blinking ping ping. So it is okay. That's good. That's good. For now, I believe I'm gonna exit my stream now. I'm just gonna cross verify what are the redundant data I need to delete. So next time we start, I'm just gonna before we close down the section, I'm just gonna rename this. Uh, send maybe send close this and transmit goes send. Okay, this data should be inside. I'm gonna change this to temp underscore data and we change this temp underscore data every place, and that's get register get register store instead of store. Register change bit change change bit change bit change bit. That is good. I'm gonna yeah, so bit position bit state, the bit state should be from this only, actually this and this. Should I use this guy? Nope. um First if I def first type def this guy and then we say bit state, use this as over here. Finally my headphones are fully charged now. Well, it's too late I guess. Bit state, I need to change it in here as well. Bit state bit state bit state bit state uh state 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 Da, da, da. Actually, I would like to test this guy. So what I'm gonna do is to check debug, add this expression I, this is good, and custom dot tada. Set, reset. Nice. Ta tada tada tada. Okay. SLEEP, SLEEP, and we do debug. Hmm. False, true, false. That is good. That's a good sign that I'm able to sleep, sleep. Stop. One, two, three. Set, reset, set. Da, 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 da. Expected this. I expected this. Okay. One, true, false, true, false. Let's go. Nice, nice, nice. Stop. Remove this section and upload this code. This way the person can like set a specific line of code, I believe. Mhm. And leave as well. Leave to 0. Mm-hmm. Nice, false. Good. Okay, nice. Good, 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 good. Right, we will stop for today, and I will continue this section tomorrow. And I believe I'm just gone. We'll continue this, but let's just write down some uh comments. La 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 la. I don't need this anymore. Mm-hmm. 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 Okay, I'm done for the day, and we will continue next day, tomorrow. Alright, guys, thanks for joining my live stream. I will be continuing this work tomorrow, and well, I'm not sure if you enjoyed or not, but I hope you guys enjoyed. If you have any questions, do drop the question in the comment section, and I'll try my best to answer those questions. So I'll see you in the next one. In the meantime, have a nice day.